So what exactly mean by the electric heating? So here, whenever it is, so electric heating we can define as a process in which electrical energy is converted into the heat energy, right? So electric heating is nothing but the process by which we convert the electric energy into the heating energy. So here electric heating works on the principle of Joule heating, right? So the basic principle of working of the electric heating is Joule heating. So what Joule heating says, so an electric current through a resistor converts the electric energy to heat energy, right? So Joule heating says that, so whenever some electric current passes through a resistor, it gets converted into the heat energy. So that is the main idea behind the electric heating, right? So now introduction. So how we can go for the introduction. So electric heating is based on the principle that, so whenever electric current passes through a medium, it produces heat is produced. So let us take a material. It is having a resistance of capital R, and the current flowing through it is I amperes for t seconds. So then how much amount of heat will be generated in that material? It is given by H is equal to I square R into T, right? So whenever I amount of current is flowing through a material for which the resistance is capital R and the time of flowing of current is small t, then how much amount of energy is generated in that one? H is equal to I square into R into T. That is the amount of heat energy that is generated in that material whenever you are passing the electric current. So now what are the applications? So where the electric heating concept is applied in our daily life. So room heater for heating the building. So if you go for in winter seasons, what happens? The rooms will be of very climate will be very cool. So what the people will be doing? They will be going for the room heaters. So these room heaters generally employ the what you call the electric heating concept, and similarly immersion heaters for the water heating. So these we'll be using daily, right? Immersion heaters. So whenever we are inserting that heating rod into the water and we switch on the supply, so after some time water gets heated up. So that is what the electrical heating. Next one is what hot plates for cooking, right? So you can find some electric stoves will be there where those will be heated by the passage of the electric current. Similarly, geysers. Geysers all we know, so we'll be using in our daily life. And electric kettles. What do you mean by electrical kettle? Anybody?
To heat the
Is electric kettle. Are you there, everybody?
for boiling purpose.
Is my electric kettle. Everybody listening?
Yes, sir.
So what is meant by electric kettle? So the these are the what you can say the equipments mainly generally used to make the tea or coffee. So here in these kettles, so what we do is we pour sugar, water as well as the tea powder, and switch on the supply. And what happens? It prepare the coffee or tea for us. So that is what we call it as a electric kettle and the electric iron, right? So electric iron, as you all know, so that uses the application of the electric heating. An electric oven for baking products, right? So oven, you know, and electric toasters. So electric toasters means what? So whenever you are inserting the, please switch off your mics. So whenever I ask, you can switch on the mics. Please switch off your mics, everybody. So electric toasters. So electric toaster means what? So for toasting the bread or bun like that. So now industrial applications. So where we are applying the electrical heating concepts in industries. So in the case of the melting of metals, so in industries, we may need to melt the metals. So in those areas, we are making use of the electric heating concept. Similarly, electric welding. So in the last class only we have discussed regarding the electric welding, right? So there we are using the electric heating concepts. Next one is what? Molding of glass for making glass appliances. So here, so for making glass appliances, what we need to do is we need to mold the glasses. So for this one also, we are using the electrical heating concepts. Similarly, the baking of insulators. So whenever we want to bake the insulators, we are making use of the electrical heating concepts. Now molding of plastic components. So whenever we want to mold the plastic components, in that case also we are using the electrical heating concept. Now heat treatment for the pointed surfaces and making of plywood. So in all these cases we are using the electrical heating concepts. So here now coming to the advantages. So what are the advantages of the electrical heating over the other method of heating? So we can heat the we can heat in some other way also. So what is the advantage of heating by means of electric energy rather than the other one? So first thing is that clean and atmosphere or free from dirt. So whenever we are going for what you can say heating by other methods, what is happening? So there might be a possibility of dirt occurring, or else you can say a smoke or fumes are going to occur. So what is happening? It causes somewhat what you can say the pollution to the atmosphere. So here this vertical heating does not produce any sort of dirt. So that is it is going to be very clean. The next one is what? No pollution, no flue gas are produced. So already I said just now. So whenever we are going to heat any material by means of other methods, what happens? There's a possibility of gases, or you can say some smoke, or something will be coming outside when you go for other methods of heating. But if you go for this electrical heating, so there is no question of all these things. There will be no pollution and no flue gases, and response is quickly, right? So it as soon as you switch on the supply, the heating process starts. So response is quickly. Accurate control temperature can made easily, right? So by means of this electrical heating, so the main advantage is that so we can get the desired temperature. So if you go for other methods of heating, so there you can't set the temperature which you require. But if you take the microwave oven, which uses the concept of electrical heating, so in that one, so what is the advantage you find there? So you can make the temperature as you require. So whatever the temperature that you require, that you can set in that one. So in that way, we can get the controlled temperature, right? So whatever the temperature that we require, that we can obtain by means of the this electrical heating. It's comparatively safe and a localized application. So overall efficiency is much higher. So uniform heating, highest efficiency of utilization, and cheap furnaces and mobility of job. So these are all the what you can say the advantages of using the electrical heating over the other methods of heating. So now transfer of heat, right? So how the heat is transferred from one place to other place. So first method is that so the heat can be transferred by means of the conduction. So here the heat transfer by conduction takes place in solids, liquids as well as the gases, right? So heat can be transferred by first method is what? Conduction. So this conduction method of heat transfer takes place in what? Solids, liquids and as well as gases. So now what is the heat transfer depends upon? It depends upon the difference of temperature between the two phases. So it depends upon the difference of temperatures between the two phases. And that is the first method of transfer of the heat energy. So heat can be transferred by means of the conduction. And second method of heat transfer is by the convection. So this phenomena takes place in liquids and gases. So this convection method of heat transfer takes place in liquids and gases. So heat is transferred due to the actual motion of the molecules. So in this one, actual motion of the molecules will occur, which will transfer the heat energy. Similarly, we have the radiation. So this phenomenon is confined to the surfaces only. That is, the radiation will be coming out of the surface from one surface to the other surface. Like that, heat energy is transferred. So these are the three methods of transfer of the heat energy. That heat energy can be transferred by the conduction, or else convection, or else by means of the radiation. Now coming to the classification. So how we can classify the electrical energy? So classification of the electrical energy. So here the electrical energy can be classified into power frequency heating as well as a high frequency heating. So in the power frequency heating, we have the resistance heating. So again, resistance heating is divided into direct resistance heating and indirect resistance heating. And again, second one is arc heating. So it is direct arc heating and indirect arc heating. So these are all coming under the power frequency heating. And similarly, high frequency heating. So in that one, first one is the induction heating. So in the induction heating, again divided into direct core type and coreless type, and second one is the dielectric heating. So this is the overall classification of the electrical heating. So now classification of the heating method, right? So so how we are classifying the heating method? So if the heating is up to plus or minus 400 degrees centigrade, that is, so if the temperature you are heating to a temperature of 400 degrees, a little bit higher than 400 degrees centigrade. So we say that sort of heating as low temperature heating. And similarly, if the range of heating is in the range of 400 degrees centigrade to 1150 degrees centigrade, so we call that one as a medium temperature heating. And finally, if the temperature is above the 1150 degrees centigrade, so we call it as a high temperature heating. This is the classification of the heating methods. That is, if the temperature you are employing is up to 400 degrees centigrade, we call it as a low temperature heating. And similarly, if the temperature is ranging between 400 to 1150, we are calling it as a medium temperature. And if the temperature is above 1150, it is called as high temperature heating. So now coming to the electric heating, right? So in what way we can classify the electric heating? So in the electric heating, previously we have seen the same thing, right? So this one only here we are showing. So in the power frequency heating, the range of frequency is 50 to 60 hertz. And power frequency heating is divided into two types, resistance as well as arc heating. And both are having direct and indirect. Similarly, electric heating, second one is high frequency. So range is between 500 to 5 to 500 kilohertz. And similarly, microwave, so which is 0.3 gigahertz to plus or minus 300 gigahertz. And again, it is divided into induction heating, dielectric, infrared, or radiant heating. So this is the classification of the electric heating. Now coming to the resistance heating. So here, resistance heating best example is what? Electrical water heater. So whatever the electric water heater we are making use, so the best example is what? That one for the resistance heating. So this method is based upon the I square R losses. Right? That is, whenever some current flows through a material, what is happening? Heat is produced in that one because of the I square R losses. So the generation of heat is done by electric resistor carrying the current. So whenever the resistor carries
సార్ వాయిస్ రావట్లేదు సార్ మీది. సార్ మీ వాయిస్ రావట్లేదు సార్.
ఒక్క నిమిషం కట్ అయింది ఇప్పుడే. రైట్. సో రెసిస్టెన్స్ హీటింగ్ వినబడుతుందా?
ఎస్ సార్.
Right. So resistance heating. So in this one, what is happening? So best example is what? Electrical water heater. So in this one, what is happening? So whenever any current passes through a resistor material, heat is produced in that one because of the I square R losses. So characteristic features of the electric heating, right? Heating elements. So what exactly the heating element should consist of? So first one is the high resistivity. So whatever the materials which we are using, wait a minute. So here, are able to hear everybody?
Yes sir.
Right. So here, this method is based upon the I square R losses. So whenever current passes through a material, what is happening? The I square R losses are going to be generated. The generation of heat is done by the electrical resistor carrying the current. So in this one, whenever electrical resistance carries the current, heat energy is generated. Next one is characteristic features of the heating elements. So what are the features that an electrical heating element should possess? First one is the high resistivity, right? So what are the element we are choosing? So that should have what? High resistivity. So second one is able to withstand the high temperatures, right? So whatever the elements that we are preferring, so it should able to withstand high temperatures without deterioration. Next one is the low temperature coefficient of resistance. So what do you mean by this low temperature coefficient of resistance? So here actually temperature coefficient of resistance can be defined as, so the change in the resistance of the material due to the change in the temperature. Okay, so whenever there is a change in the resistance of the material by the change in the uh, temperature of the material, then we are calling it as a temperature coefficient of resistance. So whatever the materials that we are preferring for the this particular heating process, so that should have the low temperature coefficient of resistance. That means the resistance of this particular material should not change with the temperature. So that is the property we need to prefer. Next one is what? Positive temperature coefficient of resistance. So we should have the positive temperature coefficient of resistance. Next one is what? Free from oxidation at high temperatures. So it should not get oxidized because of the high temperatures. So these are all the features. These are all the features of a what you can say, the elements which you are using for the electric heating. So first one is that high resistivity. Second one is the able to withstand the high temperatures without deterioration. So it should able to withstand very high temperatures without damaging. And next one is low temperature coefficient of resistance, positive temperature coefficient of resistance, and free from the oxidation at high temperatures. So these are the features that a heating element should possess for the electric heating. So next thing is resistance heating. So already we have seen initially the classification, direct heating as well as the indirect heating. So in this particular direct heating, so electric current is passed through the body to be heated, right? So in the case of the direct heating, so whichever the body we need to heat, through that body itself we are passing the electric current. So in this one, if you take, it is having high efficiency because in between, so what is happening? Directly we are passing the current through the element which we need to heat. So that's why it will be having what? High efficiency. So examples are what? Electrode boiler for heating water and resistance welding. So these are the two examples we can say for the direct heat, right? So whichever the element we need to heat, through that element itself we are passing the electric current, and hence we have the high efficiency. So now similarly indirect heating. So uh, now coming to the indirect heating. So here electric current is passed through the high resistive materials placed inside a oven. Yes, switch. Keep your mics in mute position. So electric current is passed through the highly resistive materials placed inside an oven. Transmitted to the body, right? So here heat should be, in the case of the indirect heating, heat is required somewhere else, but heat is produced somewhere else. So that's why we are calling it as a indirect heating. The best example is what? Oven, right? So in the oven, heat is produced in the oven, but it is utilized by the other materials, right? So that's why we are calling it as a indirect heating, right? So mode of transfer is by conduction, convection, or radiation. So examples are what? Room heaters, domestic and commercial cooking, heat treatment of metals. So these are all the examples we can say for the indirect heating. So first one is the direct heating and second one is the indirect heating. So you can see, you can look at the diagram there, direct resistance heating. So in that one, yeah, we have the supply we are giving to the electrodes, right? And those electrodes are being placed in the container, and so we have the high resistance powder, and whenever we are passing that particular whenever passing the electric current through the electrodes, so because the current through the electrodes passes through the charge resistance powder, and the powder gets heated up. So like this, so we are able to get the direct resistance heating. Similarly, indirect resistance heating, right? So here you can observe here. So previously in the previous diagram, so whichever the material we need to heat, in that itself, what we are doing, we are passing the current. But coming to this case, in this one, the heating material is somewhere else, but heat is produced somewhere else. So here, uh, so through that coil, we are passing the electric current, and when we are passing the electric current, heat is produced, and that heat is being utilized by the charges. So here, there is a no direct flow of current to the charges. So that's why we are calling it as a indirect resistance heating. So now, causes of failure of the heating elements. So why the heating elements will fail? The first one is of the silence.
Class Andhra.
Silence.
Shiva, me take the
So formation of hot spots, oxidation, corrosion, mechanical failure. So these are all the causes for the failure of the heating elements, right? So whenever the hot spots are forming, the heating element may get damaged, it may fail, and because of the oxidation also, the heating element may damage. Because of the corrosion, right? The heating element may fail, and because of mechanical failure. So next one is the dielectric heating. Right, dielectric heating. So what is a dielectric material? What is a dielectric material?
glass.
Huh?
Paper.
is a dielectric material?
Wood.
Dielectric అంటే ఏంటమ్మా?
ఎలక్ట్రిసిటీ పాస్ అయ్యేది అందులో నుంచి.
Wood, sir. Wood.
డైఎలక్ట్రిక్ అంటే ఏంటి అని అడుగుతున్నాను.
ఎనర్జీ ఎలక్ట్రిసిటీ డస్ నాట్ పాస్.
The electricity
Okay,
does
the
not
discrete
pass through
materials
the
are nothing but the
material.
dielectric materials. Okay, now keep your mics in off position. So here, so whenever we are going for dielectric heating, so what we are doing is, so we have the two metal electrodes will be there, and we are going to supply the high frequency AC supply. And because of that high frequency AC supply, and what is happening? The dielectric material is getting heated up. So here, in the diagram, you can easily understand. Sorry. So what is mentioning there? Dielectric heating is also known as electronic heating. So other name for dielectric heating is electronic heating, or RF. RF means what? Radio frequency heating, high frequency heating, and diathermy. So these are all the examples of the dielectric heating. So it is a special way of transforming the electric current into the heat. Right? So unlike the other methods, this dielectric heating is different. So by this, 012 mm are to be welded. So in this process, by this method, dielectric heating, so what we are doing is we're trying to weld the metals which are in the thickness of those range. So dielectric heating as generation of thermal energy in a non-conductor material by the application of the EMF or field in it. Right. So here in this particular dielectric heating, so what we are doing is we are able to generate the heat energy by applying the EMF, electromagnetic force in that one. So we are able to generate the this particular heat energy. So this is the way microwave oven heats the things placed in it. So the microwave oven which we are using daily life, so it employs the dielectric heating concept, right? So here in this dielectric heating, what we are doing, so we are applying for a non-conductive material, we are applying the electromagnetic force. So whenever we are applying electromagnetic force for a non-conducting material, what is happening? Heat energy is generated. And this dielectric heating concept is mainly used in the case of the microwave ovens. So this is what about the electric heating concept. So if anybody has got any doubts, you can just ask me. Doubts ఏమన్నా ఉన్నాయా? Any doubts so far?
No, sir.
Wait a minute.